Okay, I'm Shachar Fienblit. I'm Kaminario's CTO, and I'm really excited to be here today. It's my second storage field day, so I'm sure it will be exciting, many questions, and let's start. So, Josh, Frederick explained what we are doing today, why we are winning today. And the question and what the focus of my presentation is what Kaminario are doing next. And I'm looking at two dimensions. One is how we will further expand our differentiation in scalability, flexibility, cost efficiency. This is the core architecture, where we are today and where we are going. And the other one is innovation in simplicity. Because when we talk to customers, they tell us that storage is becoming easier. But when you look at all the layers of the IT stack, things are getting more complex with all the layers of the virtualization. And of course, there are many things that any storage company needs to do. And I will focus not just about how we are doing the backup, the integration with the cloud, the integration with the hypervisors, but also what we can do unique to differentiate Kaminario in the ease of use. So let's start with the scalability, flexibility, and cost efficiency. And I will start with some trends, technology trends, that we all need to watch. So let's look one by one. The first one is the slowdowns of Moore's law. So we're used to have double the performance every 2 years, and it doesn't happening anymore. And what we see, which is very interesting, is we're starting to see standard hardware accelerations from companies like Intel and other companies like networking companies that are trying to close the gap for the need for more performance, better cost, but it's only part of the gap. And what we truly believe is that scale-up is very important today, but because of this trend, scale-up will become even more important in the future. Second trend I would like to point is networking. So yes, we are talking about networking in the storage event, and it is an important trend. So networking are becoming faster and faster. RDMA networks are becoming standard. So we have InfiniBand, EDR, 100 gigabit internet. And if we look at the slide I used from the Open Server Summit, we also have roadmap for 400 gigabit per second Ethernet, which is quite amazing. It's so fast. And the implication is, again, it strengthens the scale out. And the reason is that it is less expensive and the performance impact is much lower when you go to a remote system. Okay, so you don't need the motivation to have the data next to the compute is lower compared to what it used to be in the past, because the penalty is much lower.
Are you guys doing anything with OmniPath?
I will go over it, but we are OmniPath not yet. But we are doing RDMA or other RDMA networks. Okay.
The only thing I don't so NVMe over Fabric.
Excellent question. I have slides about it.
Okay.
Okay. But before that, let's talk about NAND. So people were saying, okay, NAND doesn't have a future because the slowdowns of Moore's law, with 15 nanometers, you cannot make much more progress. But 3D NAND is a real progress for, and the fact that NAND is improving much faster than any other hardware element in the IT is because we have several dimensions of improvements. So the introduction of 3D NAND today, 32 and 48 layers, we see a real roadmap for 128 layers, and we also see research work to go even to 300 layers, together with the transition from MLC to TLC work, talking about QLC. It's very, very clear that at least for the next 5 years, Flash will continue to improve density and cost in a similar rate. Now, what it means, the implication is that Flash will continue to be the leading storage technology for the near future. It's not going to change. So before NVMe, we need to talk about new volatile memory technologies. And this is the new kid in town. It's a very interesting technology. But let's look at the specification. And let's talk about 3D crosspoint, but we can talk about 3D crosspoint. We can talk about other non-volatile memory technologies. But basically what it means that you get, for price which is much closer to the price of DRAM, and so it's, the price is much closer to the price of DRAM than the price of flash. And yes, performance is just more closer to the performance of DRAM than flash. Now, it is interesting because even if it's 1 microsecond, you can argue that the crosspoint can get to half a microsecond. It's still way slower than DRAM. So you can not just replace DRAM by 3D crosspoint. If you are looking at other technologies like ReRAM and others, it's 1 or 2 microseconds, which is can be like 20, 30 times more slower than DRAM. What it means is that non-volatile memory is a real revolution, but you need to use it wisely. You cannot just replace flash with non-volatile memory because it will be way too expensive. It will be the system that will be 10 or 20 times more expensive.
So it's more expensive, but are you using it in your systems? Are you using multiple levels?
We'll get there. Okay, we'll get there. We'll get there. Now we also need to remember that it's new technologies. There are some delays with 3D crosspoint, but I will talk about where we are going, how we are going to use them. Okay, because it's very important to make sure that you have the right view of utilizing these technologies in the future.
You see the NVM, is it as dense as NAND? I mean, from a volumetric perspective?
Not, you're talking about, I
understand the permanence.
The density?
Yeah.
The density is much better than DRAM. It's not as dense. It's still not as dense as NAND, but it's not as dense as NAND. Yes, it's not as dense as NAND, but it's way denser than DRAM. Okay.
Yeah.
Okay, NVMe. So we're talking about the protocol and the SSDs. So NVMe is great because it's much more efficient protocol than SCSI. SCSI is a protocol for HDDs. It's not the protocol for SSDs. And what we also see, if you look at this laptop, it has some sort of NVMe SSDs inside. For direct attach, this is actually now replacing SATA SSDs. This is Apple, so it's proprietary, but it's basically some sort of PCI NVMe sort of SSDs. But when we are looking at all-flash array, it is very interesting. Because if you look at one device, one SATA device versus one NVMe device is much, much more capable than one SATA device. But when you aggregate many of them together, like you have 24 SSDs attached to a single controller or 48 SSDs attached to a controller, the benefit is not that big. Today, the bottleneck of all flash arrays is the CPU of the controller. It's not the CPU. It's not the SATA SSD's the performance. Okay, so it's important to remember this. Okay.
Are the NVMe devices today hot pluggable?
There are solutions for that. Yes, right now. Yes.
I've heard there's not.
I will cover it.
All right.
It's early. There are solutions for it. Yes.
Yeah.
But you know it will take time until NVMe Fabric, all these elements will be enterprise ready. We are preparing for it. We'll not bring it too early before when it will be not responsible enough. But yes, there are solutions. But you know it's still early now. NVMe Fabric. So NVMe is great. It's over PCI. So why not doing it over RDMA network? And again, the benefit, why to run SCSI over RDMA network or other fast network when you can run NVMe? So this is a very natural progression for the technology. Now, when you look at NVMe Fabric, you look at external connectivity. So you can eliminate all the external latency, which is great. Now, it's a new protocol. By the way, it's very new. The spec is not closed yet. It will be closed maybe tomorrow or in the next few weeks. And it will enter the Linux distribution this year. So it's still not enterprise ready. But as a new technology, people are not throwing away iSCSI in Fiber Channel tomorrow. It's better technology, so there will be a transition into NVMe Fabric. But Fiber Channel and iSCSI are not going away. So it's another and more efficient protocol. And every array should support NVMe together with iSCSI and Fiber Channel. NVMe network shelf. So, okay, outside it will take some time. It not only depends on the storage vendor, but what you can do inside your array. And this is a very, very interesting technology. What this basically means, I will not mention the names of the vendors that are developing it. By the way, it will take, again, for your question, it will take some time until this type of technology will be production ready for the enterprise. But this is the future, okay? It's basically, instead of a shelf full with SAS SSDs and SAS connectivity, you have a shelf full with hot pluggable NVMe SSDs, and the connectivity is NVMe Fabric. Now, most of the solutions are a RoCE InfiniBand 100 gigabit per second connectivity to a shelf. What it means that it's bring a real opportunity to build better storage and to further improve the decoupling of capacity from compute. And we'll cover it in the presentation. So all these technologies are very fast. So you can ask yourself, okay, what is the opportunity here? To build a much faster storage than the current AFA generation. And let's look at some facts. So on the right, what we have is a graph built by Intel. What they basically measure is the latency breakdown. It's the latency breakdown of different technologies. But what it's basically saying, it's without all other layers of the stack. What it's basically saying is that majority of the latency is coming from flash. And if you replace flash with NVM technology, you are eliminating it. But guess what? It's very expensive. It's not in production yet, but it will be very, very expensive in the next at least 5-6 years. Now, if we look at some facts about all flash arrays, which are also important to mention, the CPU of the controller is the main bottleneck of any all flash array you will find in the market, even with SAS and SATA SSDs. This is one fact. The second is related to this graph. 50% of the latency is coming from the flash media. So if you are just improving the latency to get to the media, the best you can do, even if you eliminate it to 0, it's to improve by 50%. And I say the CPU of the controller is the main bottleneck. So what are we doing with this controller? And the main thing that are done with the controller for enterprise systems are two: data services, snapshot, replication, all these data services, what enterprise customers are expecting to get from a storage system, and data reduction in order to be efficient, deduplication, compression. So what does it mean? So yes, you can improve performance of AFA. Most customers will not ask for 3 or 4x performance improvement, but you can do it. But you can do it by eliminating the software, most of the software stack, most of the data services and data reduction. So you can build a solution, much faster solution, but which is much more expensive. NVMe Fabric connectivity will cut most of the external latency, which is very important. And it will be an important improvement for networking. But as long as we continue with flash media, the main bottleneck will remain the latency of flash. So what we truly believe is that history repeats itself, and cost is king. And yes, you can build the new next generation tier 0 system with these technologies. Is it interesting? Yes, some companies will build this solution. We believe it's not interesting enough because we want to look after the majority of the market and not just the niche new tier 0 market. So the question, okay, what we can do with these technologies, because it's a real change that we need to gain the maximum benefit out of it. So let's return back and look at the trends and what we can do with them. But before doing it, I would like to remind everybody what are the main architecture differentiation that we have as a company and how we can utilize this, because we want to utilize the benefits that we have of our architecture in Kaminario. So the first and the most important one is the virtualization layer that we added to decouple capacity from controller compute. This is how we are able to scale up, to scale out, to do the mix and match, to do the perpetual array that Josh was describing. This is a real technological differentiation. The other item is efficiency of metadata. And the one thing that I want to mention in specific, we covered it in the session last year, that we do not assume that all metadata resides in memory. This is very important when you introduce technologies like 3D crosspoint, and I will explain why later. And the third is that we are very, very efficient. We are dealing with flash. We want to be very efficient and to use the system as a general purpose storage system. So our adaptive block size means that we are very efficient with memory and CPU. And the fact that we are very optimized for endurance means that it's not that we will only be able to deploy the flash technologies that are available today, but also the future flash technologies that are coming with the challenge of lower endurance compared to what we have today. So let's look one by one. So leveraging advanced in NAND, so NAND will continue to improve. And the advantage that we have with our endurance optimized architecture is a significant advantage that we have today, but it will become even a greater advantage in the future. So there are some vendors that are able to deliver flash today without all these optimizations, but it will become impossible because as the endurance declines, it's becoming impossible to utilize the most cost-efficient flash that is available.
So Shachar, in the K2 block today, you're using 3D TLC NAND SSDs, so 3.2 terabyte size NAND flash devices?
So we are using 3D NAND technologies. You can put multiple shelves, so you can put 3 shelves with Kaminario.
And they're SAS connected today?
And this is SAS connected today, yes. SAS connected today. Non-volatile memory. So we are not replacing flash with 3D crosspoint or some sort of non-volatile memory. But what we'll do, we'll replace DRAM caching of data and metadata with this technology. And actually, let's remind you that I said that our metadata implementation is very scalable. And our metadata implementation does not assume that all DRAM resides in memory. If you assume that all metadata resides in memory, when you need to add 3D crosspoint, then you need to rewrite the code. Because if it's like 8 or 20 times slower, you cannot use the same code that assumes DRAM and move it just to NVM and assume that it will work in reasonable performance. The fact that we are doing it already today to do the caching into flash allows us to really move to NVM in a much, much easier way than any other vendors. Leverage NVMe, NVMe Fabric.
So you don't see NVMe as a replacement for a DRAM data cache, just metadata cache?
I see it, but you need the right architecture. So yes, I actually see it. This is what we, NVMe technology will do it. Now the question is whether the architecture is ready for this transition. Because if you assume that all metadata reside in memory, you're moving to this media. So for instance, if your internal metadata structure is like, let's say, B3. So you are optimized to low number of access to the slower media. Now, NVM is very, very fast. But compared to DRAM, it's not fast. So if you can just taking a code that assumes DRAM speed with many accesses to the DRAM and move it to NVM, it will be very, very slow. Now, you cannot continue to increase the size of the DRAM, again, because of the slowdowns of more slow. So you must move to these technologies. And the question is whether the architecture is ready to deploy these technologies or you need to rewrite all your metadata. OK, is it clear? Excellent. OK, now it's becoming even more interesting. NVMe, NVMe Fabric. So we see external connectivity of NVMe Fabric is a great evolution, but it will take time until it will be deployed. As I mentioned, it will take time until it will be enterprise ready, and it also depends on the implementation of customers. They are not going to throw away all the fiber channel and iSCSI investment in one day. It will take time. So we see NVMe external connectivity as NVMe Fabric as a new feature for an array. So you will support, system will support iSCSI, fiber channel, and NVMe over Fabric probably some sort of rocky Ethernet, which will probably be the leading one. This is at least my guess. But the main opportunity here is to further improve and to really improve the decoupling of controller compute from capacity. This is what we are doing today. But this technology will make it even stronger. So let me explain what I'm suggesting here. So if you look at this chart, this is our storage system will look like. OK? Controller, compute, and the storage, which is network shelf. What is network shelf? Is shelf, as I mentioned, with RDMA Ethernet connectivity. And the way to connect between them is through RDMA network, fast RDMA network. And each controller can see any of the storage, OK? So in this architecture, you can take the decoupling of capacity from controller compute to the next level, because you can add compute resources in the most granular and flexible way, as well as storage. So it's a real separation of capacity from compute, will really bring the maximum flexibility to customers like Frederick that can really scale their environment in the most cost-efficient and optimized way to meet their needs. Now, what's very nice about it is that we thought about this concept of decoupling capacity from controller compute upfront, and K2 architecture is ready for it. Now, these network shelf, it will take time until they will be ready. There are vendors that are working with it. I will not mention their name because of NDA, but it's the, let's say, the typical suspects you may think about. We see that these are the type of solutions that you will see 18, 24 months from now. Yes, today, for your question, it's not production ready yet, but this is how data center will look like. By the way, this is also how hyperscale vendors like Amazon will build their data center as well. So it's not just about enterprise storage, it's about a more significant revolution in the data center and the hyper-converged data center. Questions?
So NVMe is so fast. I don't know how many storage blocks you can have out there that can support. How many? I just don't. 100 gigabit doesn't seem fast enough in this environment.
By the way, 100 gigabit, it's not the world record of performance.
Yeah.
What we are trying to accomplish here is to build a better and more flexible system. We are not trying to build an new expensive array, tier 0 array, and to break the record of performance. This is not what customers are asking. They are asking for better flexibility, better scalability, better cost efficiency, because this is their general purpose storage array. And yes, even with this architecture, in order to utilize all this NVMe, you need to put too many controllers, which will be too expensive. So it's actually not going to be the network. It's going to be cost efficient to not put too many controllers.